Hi. The topic for today is going to be considerably shorter than my previous video, and we're going to talk about the electrical system for the solar tree. And this being a solar power project, I'll start with the solar panels. There's 9 of them, they're made by Renogy, and each can output 50 watts maximum. That gives us a theoretical maximum output of 450 watts. The only condition where we would actually get that 450 watts is essentially a cloudless sky at noon. But, of course, we're never going to have that for 99% of the time, so output is automatically down from the 450 watt theoretical maximum. Now, there's 3 other things that could bring down that expected power. One is that we have panels wired in series, and when you wire solar panels in series, the maximum current that the set can output ends up limited to whatever the current output is of the weakest panel. Similarly, if you have panels wired in parallel, the maximum voltage that can be achieved is limited to the voltage of the weakest panel. The last condition that could cause the panels to not output the highest power that we expect is if they are hot. As temperature goes up, efficiency goes down. So, let's see how these panels are all wired up. Each panel has a pair of cables coming off of it, terminated in waterproof connectors. Waterproof connectors are great at being waterproof, but they're not so gentle on your budget, and they are a little bit annoying to work with, especially since they're all separated like this. So, as soon as we can start making electrical connections inside the waterproof body of the tree, or at least water resistant, we do so. And those connections are made by 45 amp rated power pole connectors. These are considerably easier to connect and disconnect. They're also rated for a little over double the highest current we expect to see anywhere in the electrical system, never mind the highest current from any of these solar panels. They're rated for 45 amps, and the highest we expect to see anywhere in this system would be 20 amps. The wiring itself is similarly overrated. It's all 10 gauge, which will be able to handle 20 amps with no problems at all. Going down a bit shows the rest of the power pole connections from the solar panels. Yellow shows anywhere where a shrink wrap and solder connection needs to be made, and then down at the very bottom, that's the connection that comes out of the base of the tree and goes into one of the benches where the rest of the electrical system resides. The rest of the electrical system starts with the MPPT, or Maximum Power Point Tracker. The main job of the MPPT, as the name suggests, the point of maximum power for the solar array. Essentially what it's doing is it is analyzing the current that it can get from the panels and the voltage it's getting from the panels and finding the point where their product is largest. In other words, the maximum power point. This MPPT is actually kind of special because not only does it charge the batteries from the solar panel, it also provides a monitored output. And by monitored, I mean that it takes care of the batteries to ensure that you cannot over-discharge them. That's a little bit unusual. Not all MPPTs have that feature. And this MPPT is made by a company called EP-Ever. It's a Tracer 2210AN, which has a maximum output of 20 amps. Hence the 20 amps that I quoted a minute ago. The batteries, like the solar panels, are made by Renogy. There's 2 of them in series, they're 12 volts each, and they have a capacity of 100 amp hours apiece. That's 200 amp hours total times 24 volts, gives us a total stored energy capacity of 4,800 watt hours. Now, you might also notice all the fuses surrounding the MPPT. Those are there just as an extra layer of protection, just in case anything weird happens. So, up top is a bunch of publicly accessible USB ports for charging phones, tablets, whatever. Each of these pairs of USB ports is in one bulkhead, and each of the 3 benches will take 2 bulkheads. So, 12 USB ports total for people to use while they visit the tree. Now lower down you'll see an inverter in yellow with some AC outlets on it. That came about as a future expansion idea. Currently there are no devices that actually need AC power, but we've accounted for the concept of adding that power should the need arise. Another thing about how the 24 volt system is set up. All of this all of the 24-volt side will be connected using screw terminal blocks. There's just no reason to use power poles on these connections because they will not be made or broken according to when we take the tree down or set it up. They'll be somewhat more permanent because they're all in the base of the tree. Not in the base, in the benches. Next thing is all of the 5-volt gear. There's a DC to DC converter which converts 24 volts to 5 volts, and the primary user of that power is the Raspberry Pi. It controls the weather station, and it talks to the MPPT. Talking to the MPPT is a little bit of a chore that has not been figured out yet because the protocol that this MPPT uses hasn't been documented by anybody. The maker assumes that you're going to use just their Windows software to interface with it. We're not using their software, and we're not even using Windows, so that's a little bit of work that's cut out for us for the future. The other thing that's a sort of future expansion is getting data uploaded to the internet. And assuming we're in range of Wi-Fi or we're close enough to be able to run an Ethernet cable, we won't need the hotspot in order to do that. But the tree won't necessarily be set up within range of such options. So we've accounted for the fact that we may need a hotspot in order to connect to the internet. The last part of this electrical setup is lights. And given that that is a purely aesthetic part of the electrical system, we're dealing with some pretty vague electrical requirements. So for now, we're assuming that the lights will run on 24 volts and that they will be dimmable by pulse width modulation driven by the Raspberry Pi. So that covers the entirety of the electrical system, and I'll see you in the next one.